For example, this is black cohosh. If in the upper left corner you see its native range. Black cohosh is one of the top 10 selling botanical supplements in the U.S. It's sold majorly in Europe. It only grows native in the portions you see here. In the entire world, this is its distribution range. So in Europe, it's a huge product. They came and got our germplasm. They're growing it in Germany. They're selling a product, Remifemin, which is the largest selling cohosh product, and they're shipping it back to us here and we're buying it. So what we'd like to do is we'd like to get a more of a competitive edge for our growers, and so the only way we can do that is to be smarter. And so what we do is when I develop a germplasm collection, you see these dots on this map. This is what I would do. I would want a population representing the entire range. Then I collect from all of those sites. We compare the triterpene glycosides, and we also compare the bioactivity in studies. We grow out all of these in controlled pollination regeneration cages. We pick the 2 best cultivars, and we use basic traditional methods, and we breed the 2 best cultivars to develop a regional cultivar that will give our growers perhaps a competitive edge, and that's what we're working on right now with this particular. But that's sort of the strategy of what you do with a germplasm collection. Quickly, differences between a botanical garden and a germplasm facility. A botanical garden is usually just a collection of living plants. It's a public garden with an herbarium optional. A germplasm facility is much more research-based. We have a DNA sample collection storage. Herbarium is a huge part of it. We don't accept anything without an herbarium voucher. It's a long-term seed storage facility. We do research distribution. We publish our results. And we also have a backup seed storage site. We try to get backups of everything that we collect, and we would put that at a second site. So we do acquisition and exploration. How am I doing on time? We do regeneration and evaluation of the seed. When we get them back, we try to develop seed studies so that people learn how to propagate them and replicate the seed studies. We do pollination control propagation. These are cages in the field. We grow the accessions in the field so that the seed, if it were to become an invasive, it's controlled in a cage. We put bees in the cage to keep our genetic integrity intact between the accessions. And it's a very, very controlled method. We use a certain number of individuals so that allelic diversity is represented accurately and our genetic diversity is not decreased so that we don't get bottlenecking. The seeds are harvested and dried. They're cleaned with specific machinery, and then they're sorted and picked. And then they're stored. And the seed are stored, they're vacuum sealed in these tri-laminate patented foil packets because oxygen messes with the long-term storage of the seed. They're stored at minus 20 degrees C for long-term storage. And then we also prepare samples for researchers to use. What we do is we come up with a list of researchers who are, for example, we're working with somebody at ASU who's looking for anti-inflammatories. We come up with a database of anti-inflammatories and put those on our target list to collect for them. We have somebody in Iowa looking at anti-inflammatories, also in antivirals. We have other people who are looking for alpha and beta estrogen receptor binders. So we work with specialized researchers across the country who are sort of the best in what they do. We can target them and supply them with plant material that they know can be repeated in the future for research. And then they share the research with us. And then we also have it on an accessible database. Our collection targets are not just vascular plants. We're also looking at lichens, ferns, spores, fungi, bacteria, and also endophytes, which are associated with some of the species. Endophytic fungi are a very interesting, brand new area of research, or relatively new. Some examples of them are penicillin, Taxol, camptothecin, and podophyllotoxin. And these are more like drug-like compounds. And what they found is that, for example, Taxol is the yew tree. Taxol is extracted from the yew tree. They found that there is an endophyte, which is a fungi growing under the bark, that expresses the Taxol. So if you can get that done in vat culture, you wouldn't have to kill the tree to make the Taxol. You would grow the fungi and have it express it and do a vat culture, which is how they actually produce penicillin also. And podophyllum from our mayapple, podophyllotoxin, has also been used the same way. It's used for testicular cancer. So we have loads of collaborators, and these are a few of them that we're working with just in this, just sort of regionally in the southeast. And what we're doing is we've got plenty of people interested in projects, but we spend most of our time right now writing grants to fund the project, to bring in more help, to get technicians, and so that we can have enough foot power to supply samples to all of the people on this particular list. This is Prunella vulgaris in the upper right corner. It was interesting plant that I just mentioned. We found some very interesting anti-inflammatory and antiviral activity with it. It has a long history of use. It grows native, and it's also been introduced from Europe. And then in the lower corner here is a Hypericum gentianoides that I also collected in South Carolina and North Carolina that has had a new mode of action found that's antiviral that nobody actually expected, and some new molecular structures were found in that plant also. And with that, I want to thank you and some of the local, regional people in Asheville who have been very, very generous in support for our project. There's a question back there. Are we taking questions?
Yeah, we go right for it.
For Joanne, how long is long-term storage? Do you need to occasionally plant the plants out for the seeds to be viable?
Excellent question.
It sounds like you're dependent on grid power to keep that temperature. What if you lose grid power?
Very good questions. Okay. First of all, we would try to do seed studies every 5 years unless we know that the seed lasts 75 years. Some seeds last 5 years in storage. Some last 100, 200, 1,000. They're all different. So there are published research on some of the species. If it's not published, then we do germ tests every 5 years, grow it out, and get more seed. Or what we would ultimately do is go to the original population so that you preserve allelic diversity. That's a really good question. We have backup generators for every freezer that is plugged into the wall in case something does happen, and we just pray that it doesn't. But we also use the Nordic Gene Bank as our backup repository, which is in the side of a glacier in Norway. And so we have that as a second sort of
So
backup.
a copy of everything goes to Norway.
Yeah, and it hasn't started yet. We've just been negotiating with Kerry Fowler, and we have the agreements. He's actually from North Carolina, interestingly enough.
Thank you.
Good question.
Oh, and do you make seeds available at Roller?
Well, what we do usually, we're in our, and I didn't mention that, we're in our second year right now. So we're not making anything available yet because we don't have everything screened, and we don't know which to say is the best cultivar yet for things. But we will be doing that. Normally what a gene bank does is you would order the material from the gene bank. They're going to send you a couple hundred seed, and then you grow those seed and produce the more seed yourself. And I must tell you that the federal system in North America, GRIN, has anybody here used GRIN? It's a database of all the germplasm in the U.S. You can order from GRIN freely, and it's a federal, you can order seed and they'll send them to you free. And they'll send you like 20 accessions of one species if the species that you're looking for is on there. They don't necessarily have medicinals covered well. But for example, they have 200 accessions of Echinacea, representing all 8 species. So you could do some interesting research with that.
Tom?
Yeah, I have a question, and this is sort of a general question for anybody on the panel, though it probably has more bearing on the farming and the germplasm project. It's a known fact that this area has a significant increase in air pollution in the form of aerosols and in the form of ozone. That can result in things raining out. It can result in respiratory disease, and it can affect the amount of sunlight reaching the ground. Do you see any evidence of this, or are there concerns about the increase, particularly in aerosols, as a result of that? Do you see distress, respiratory distress in animals as you do in humans? And also, do you see any change as a consequence of the air quality in terms of the growing conditions and the things that you can grow?
I have no idea.
I know from a germplasm point of view, there's definitely a lot of effects in the higher elevation, like in the heath balds and the spruce fir zone. There are a lot of stress effects there, very evident. So we want to get there as soon as possible and collect as much as possible. And that's also a habitat that I think North Carolina has more spruce fir zone than any other state in its particular region, and it's really getting pushed out. There's nowhere for it to go. It's already being pushed. So that's how we're looking at that. There's definitely signs of it.